Welcome, my dear students. I am Dayakar, belonging to Department of Engineering. I am going to handle the course Ground Improvement Techniques. These are all natural soil deposits, whereas when we have the man-made things like dumping the solid waste, this uncontrolled fill will possess very low strength and high compressibility and non-uniformity and high collapsible potential because the fill is not controlled. Okay, just they are filling the waste in a low-lying area. Or if you have a dredging material, maybe a river bank or a seashore, but they contain high water content and low strength and high compressibility. Or if you have a reclaimed fill, there also the high water content is there and low strength and high compressibility. When we have the recycled material, then there are chances for non-uniformity and high variability of the property. And if we have solid waste, then it has got low strength, high compressibility, non-uniformity, and high degradation potential. When we have bio-based byproducts, it may have low strength, high compressibility, and high degradation potential. So these are the potential problems that we may expect from these soils. So accordingly, we have to think of a solution and then make the success case. And that is why we have this tower. What is it called? The Tower of Pisa, which is Italy. Do you think that they have constructed in this inclined manner? No. It was originally constructed vertically, but because of the soil below, because of the secondary consolidation, the building started leaning. Similarly, in Orissa, there is a temple dome which is leaning because the soil below is the problem. And there are lot of building failures in Shanghai because of the problem with soil. So these need to be addressed. These problems need to be addressed. Why it has failed and what are the remedial measures. And not only that one, many times we can have this type of sinkhole. That means initially the building was good. So we have checked the ground and then based on the soil properties only we have constructed this building. But later on, suddenly one fine day, the entire thing collapsed. That is called sinkhole. That is called sinkhole. Why is it happening? Why the sinkhole system? The principle or the reason behind the formation of sinkhole is this one. So we can have rainwater which is acidic, and because of the acidic water, if the ground is having any limestone, then slowly the acidic water reacts to the limestone and leaching takes place. That is, movement of the soil along with the water takes place through the cavity and it slowly forms a bigger sinkhole. So that is why initially we will not be knowing the ground. Yes, it is good. Yes, we can construct. But later on, because of the acidic water, because of the acid rain, then the leaching takes place and everything below is washed away or lateral movement is there and one day we suddenly see a sinkhole. So this has to be avoided. So here this is a clear indication of that small bedrock is there, small what is percolating is there because it's a limestone and slowly it reacts with the clay and the soil keeps it place and slowly the soil completely comes and then there is a sudden what big open, okay, in the form of a funnel. So this is how the seafood perform. And also we have this frost heave. which is due to the freezing and the thawing effect. Okay, during the daytime, the temperature is more, so water is in the form of vapor, and during night time, this vapor enters the soil, so the temperature is reduced. That is, the water vapor becomes ice cleanser. When it becomes ice cleanser, the water molecules increase in volume. When it is increasing volume, then it is exerting pressure on the soil. That is why heaving occurs. It is called frost heaving. So because of that one, you can also have some of the pavement heaving. So the layer below this one is subjected to freezing and thawing, and thereby you can have failure. And also you can have this liquefaction. How this liquefaction occurs? That is because of the sudden earthquake. That is, the sand is saturated, and if there comes a sudden earthquake, the soil completely loses its effective stress, and it becomes liquid like mud. Sometimes the ground also cracks. It is cracking because of the what reduction in the moisture content. Then you can have earthquake. Sometimes you can have the ground heaving also. That means there is increase in the moisture. So if the clay is there, the increase in volume that is being affected. And this is a classical example of the 1964, where the entire structure, that is apartment complex, has overturned. Okay. Similarly, during the Bhuj earthquake in 2001 in Gujarat, we have a lot of earthen structures which are what failed. You can see the cracks which are very deep, very deeper in there. Also, the rubble masonry which are constructed failed or collapsed. Foundation rubble collapse. Okay. Also, we have unstable rock failure because of this wood earthquake in 2001. Also, there is a slope failure, soil slope failure because of this wood earthquake. So, earthquake is a major danger. That is why we have to think of the earthquake prone areas and accordingly suggest a very good ground improvement technique. Now, why we have to study the geotechnical structural failure? Because we want any design for the geotechnical failure. So what is the any design? It should be economical, it should be safe, it should be durable, and it should be strong. Okay. There are so many ground improvement techniques. That is what we have seen earlier, like the ground improvement, ground treatment, and ground reinforcement. So we have to think about the structure, and based on that, we have to find a suitable ground improvement technique, thereby it is economical, safe, and durable. Okay. Now, what is this ground improvement? Ground improvement is the basic operation is increasing the soil density or soil unit weight. When you increase the soil unit weight, automatically the load carrying capacity. So how can you increase the load carrying soil density or unit weight? By removing the air wire. By applying compaction, you can remove the air present in the water. Also, the pore water pressure can be reduced or pore water is expelled from the soil. Thereby, the soil particles are made to come closer, and because of that, the density or unit weight is reduced. That is the basic operation in ground improvement. Whereas ground treatment is, we are going to change the soil property by adding some binding material. like fly ash or slag or cement or chemicals. It's admixture. That means we are completely modifying soil properties by mixing the uh, soil with the biomaterial and the ultimate property not only based on soil, but it is of the soil as well as this property only we are going to see. And if you go for ground reinforcement, the basic operation involved, we are introducing a reinforcing material into the soil, and that reinforcing material is going to take up the load. So the major load is taken by the reinforcing element, and the surrounding soil is supporting that. So these are ground reinforcement techniques. Now we'll go on for the ground improvement, where we can see the basic method of compaction. So this is the simplest method. That is, field compaction is the simplest method in which or by which we can improve the ground, because it is very less expensive method. That is why you can see this is widely adopted or used for laying the road, or in case you are going to construct a multi-story structure for a large area, first thing is to improve the field compaction using the roller, where you don't require any skill. Only thing is you require a smooth field roller and a driver, and you can sprinkle some water while rolling, thereby simply by applying the rolling, that is by applying the weight, the compaction is achieved, thereby the bearing capacity is increased. And also, this method is very uh, useful for both cohesive soil as well as non-cohesive soil, that is clay as well as sand. Now, what is that we are doing here? Almost all we have shown that in the soil mechanics or during engineering, you know what is gamma D? What is gamma D? It is a tri-unit rate. So this tri-unit rate can be expressed as gamma B by 1 plus W, where gamma B or gamma T is the total unit weight, and if you know the moisture content of the soil, then you can find out the gamma D. So if this gamma D tri-unit rate is increased, then we understand that the soil is more stronger. That is, only at a particular moisture content, that is OMC, optimum moisture content, we can have the gamma D max, maximum draining rate, and if you are able to achieve that in the field by the compaction, then that is the simplest method. Now, this field compaction is achieved by using these various equipment. What are they? The first and foremost is simple smooth wheel roller. Okay, this is a big drum, steel drum, which is rolled over the soil, and in this method only we are having 100% coverage on the, that is, the contact of the area of the soil and the wheel is 100%, and the contact pressure can be up to 380 kilopascal. Now, this method can be used on all surface soils, that is cohesive as well as coarse and less, but for rocky soils, it cannot. And here, the compacting effort is nothing but the static weight. The weight of the drum is applying the pressure on the soil, thereby the loose soil is compacted, or the voids in the air in the voids are expelled, thereby soil particles are made to come close. And the most common use of large smoothing rollers is for proof loading subgrade or compacting the asphalt bed. So for pavement, the subgrade is most important. That is the foundation. So there only we adopt this technique. Thereby we can compact very large area within a short time. Nowadays, we are also using this pneumatic referred as rubber tired roller. This covers only 80% under the wheel. The contact area is only 80%, whereas the contact pressure is up to 700 kilopascal. Now, this can be used for both granular and fine grained soil. And here, the compactive effort is static weight and kneading. I think knowing what is kneading, it is blending or mixing the soil. For example, if you have a clay soil, if you use a smoothing roller, when the load is lifted, the soil may eject out from these fields. Whereas if you use this type of roller, that is pneumatic tire roller, the gap in between the wheels will be there, thereby we can knead the soil, the clay soil, thereby the compaction is achieved properly. So this can be used for highway fields or FM dam construction. And another one is sheet foot roller, where you can see the surface of the roller is having a feet-like attachment. It is like a sheet foot. And why this is provided here? Because if you want to compact the pure cohesive soil, that is clay soil, if you use a smooth field roller, it is very difficult to compact because when you apply more and more load, the soil will eject out on the side. Whereas if you use this type of sheet roller, only the air will be ejected out through the gap between the sheets. But here, the coverage is only 8 to 12%, and the contact pressure is around 1400 to 7000 kilograms. So this is the best suited for clay soil, and here also the compactive effort is static weight and this is the what the sophisticated roller only to be applied in the plant. Also, we can have stamping foot roller where the coverage is only 40% and the contact pressure is around 1400 to 8400 kilograms. It is best suited for fine grained soil like hill as say. Here also you can see the foot stamp is there somewhat bigger than the sheep food, thereby the soil is not allowed to go out of the roller, whereas the because of the application low, the air is allowed to escape through these tubes. Now here also, the compact effect is static weight and sometimes you can also go for mesh roller or this pattern where it is suitable for rocky soils or gravel. Here, the coverage is only 50% and the contact pressure is around 1400 to 6400 kilograms. Because the gravel, if you use a 2 roller, it is difficult to compact. In such cases, you can go for this type of big pattern roller or mesh roller, whereby it is properly compact. Sometimes it is also fitted with the vibrator so that it can vibrate, and because of vibration skills, the gravel will be what compact. So here the compact effort is static weight along with that amount of vibration. Also we have this vibrating drum or smoothing roller on smoothing roller that is with the weight or static load, we are introducing some amount of vibration, and because of the vibration, the compaction is achieved very quickly. Okay, so because if you use one-day roller, it will take longer time, so there is a development required. So we are introducing this vibration. So because of vibration, the compaction process is enhanced. The best expression of why roller vibration causes density is that particle rearrangement occurs due to cyclic deformation of the soil produced by oscillation of the roller. So these are suitable for granular soil. That is particularly the coarse sand or the gravel. Now this shows a summary of the equipment used. That is, when you have 100% clay, the best equipment is a sheet-put roller, whereas if it is 100% sand, it is vibratory. Or in between, you can use these different types of rollers. And in case of rock, you can go for what? Grid roller. In all the cases, you can see there is a static weight and then kneading. And in some cases, static weight and vibration. Okay, so this will be helpful for selecting a particular type of method that is efficient for the soil. Now, what are the variables that we have to consider while doing this compaction? That is, variable compaction. Now, we have to understand what is the mass and size of the compaction, and what is the operating frequency, and what is the frequency range. And we also should know what is the status of soil, what is the initial density, and what is the grain size, and what is the content. Accordingly, we can use a particular type of equipment, thereby we can achieve the required compaction with the plant. And also we should know what are the construction procedures. That is, for that particular type of soil, what are the number of parts of ore required, and what is the lift thickness, and what is the frequency of the vibrator, and what is the towing speed. That also should be known. Generally, we can implement that method efficiently. Now, coming to this dynamic compaction, earlier we have seen the surface compaction or field compaction, where the compaction is achieved only for a lesser depth. That means the surface layer only is compacted. Whereas when we require the soil below the surface, maybe in meters, maybe 2 meters or 3 meters, has to be compacted, then we have to go only for this kind of compaction. So when we have to go for, when the existing surface or near surface soil is poor, which is not the foundation support, then we have to go for dynamic compaction, which will do deeper compaction. For which type of soil we can adopt dynamic compaction? Both cohesive as well as porcelain. How you are going to do this dynamic compaction? By dropping a heavy weight, maybe 2 to 20 tons, a big hammer into the soil. That is dropping from a height of 20 feet to 100 feet, like maybe 6 meters to 30 meters. And how we are going to do it? Dropping randomly, or we can follow a grid pattern, and using that grid pattern, we can easily achieve the required compact. So this is the photograph showing the dynamic compaction, wherein we are having a tower which is having the weight supported by the steel rope. So this weight will be taken to this side, and then it will be dropped. So we'll be having the energy, and because of the drop, the loose soil gets compacted, and we can see the crater form due to the dropping of the hammer. Now, if you want to find out what is depth of equation for dropping of this hammer, is given by this simple formula, where D is depth, which is half of WH power half. That is nothing but 0.5 root WH, where W is the mass of the weight falling in metric tons, and H is the drop of high in meters. So if you're able to find out this one, we can find out what is the depth of influence. So these are how we can follow a grid pattern, and then after this dynamic compaction, a roller or a leveler can be used to level the soil or level the field, thereby the compaction is achieved. So this is the equation that D is 0.5 root WH. In case of for in less soil, whereas if it is a cohesive soil, the point 5 is not there, divisible root of WH. And the technique involves a repeated dropping of a large hammer from a crane, and this is the weight and this is the height. So these are it will be done. And if you have finishing cases, depends upon the energy input, that is weight and the height. And this picture clearly shows that when the weight is dropped from the height of head, it is causing the vibration. It is causing vibration for the soil layers below in a larger diameter, and that is why the dynamic compaction occurs, and it does that for a greater scale. And this is the pattern that we have to follow, like this is the primary part. That is, initially you have to go for this one, and next this one, and next this one, and next this one, like that. And then only in between is again drop. So alternately it drops, and finally we get the entire area is completely compacted by this dynamic compact. And here we can say the spacing is very important for this dynamic compaction, because as the space increases, the depth of compaction also, as the space decreases, the depth of compaction also decreases. Similarly, the height also. As the height increases, the depth of compaction also increases. So deeper layers of compactor are wider with spacing, and upper layers of compactor with closer spacing. This is what we have to understand in case of dynamic compact. And these craters are formed, and these craters are filled with the sand, so that the entire area is completely compact. Okay. Normally, the heaving around the craters are very small. It is a but because in this soil, whereas in the first soil, sometimes it may be bigger. And next is the Vibro-Compaction. We can go for vibrating soil, and then we can apply the phase with the some other material. That is called vibro-flotation. So these are techniques which is in situ densification of thicker layers of loose granular soil deposit with some other material. So this technique also is very sophisticated, but very fast. Now there we have four stages of vibrophotosis process. The first stage is we are going to introduce a jet at the bottom, so that it is making a room, that is, it is forming a borehole-like structure into the ground in the loose soil, so that the jet will be ejecting out all the loose materials. It causes a thick condition. Because of that, it causes thick condition in soil, and it allows the vibrating unit to sink into the ground. So when it reaches the required depth at stage 3, now you are going to pour the granular material from the top of the hole. What is the granular material in blue metal or ballast? So when you are pouring that into the space that is created with the vibrating, because of vibration, the granular material is compacted, and thereby the entire space is filled with the granular material, and also it is compacted. Thereby the entire area is what becoming what hard. Okay, I think with this the ground improvement technique for this session can be over, and you can follow these different books like Reinforced Soil and its Indian application by Swami Karan, or Ground Improvement Techniques by Purushottam or introduction to geosynthetic engineering. I think that is not clear. And introduction to soil reinforcement and geosynthetic by